So now let's turn our attention to number 4 and remind ourselves a little bit about how we solve trig equations. So let's take a look here at number 4a to try to get a sense of how exactly we can do this. So we're dealing here with an equation of 2 times the sine of theta is equal to square root 2. And our instructions here are just to solve for all possible thetas that could make this work. Notice there's no angle restriction right now on theta, like solve for only the answers from 0 to 2 pi. Here I'm dealing with all different possible values of theta that could make this work. Well, the first thing that I'm going to try to do here is to simply go ahead and just isolate sine theta on its own side. So here I'm just going to end up with that the sine of theta is equal to the square root of 2 over 2. Now once I have this, I could start to think carefully about my unit circle, which is a really great way to try to start reasoning through a question like this. And I could say, okay, if the sine of an angle is going to spit out the square root of 2 over 2, then where would my angle be forcing me to look at in the unit circle? Well, it would have to be forcing me to look over here in either quadrant 1 or in quadrant number 2, because the sine has to produce a positive value. And remember that the sine is representing the y-coordinates of points on my circle. So there would be 2 points here that are going to land at a height of square root of 2 over 2. Now I have to figure out what angle would I have to be looking in the direction of. Well, the weird part here is that there are infinitely many angles that could do this, but let's just start by finding 2 simple ones. You might recall this first one, could just be written here as something like pi over 4, right? An angle of pi over 4, or equivalent to 45 degrees, would allow me to look out through this particular dot on the circle. But I also have to deal with the angle that would be facing in this direction, so a rotation all the way up to here. And you might recall that as an angle of 3 pi over 4. But again, these are only just 2 possible angles. You could easily imagine that I could be standing at the origin, staring at this red dot, by starting looking down the x-axis and rotating those 45 degrees. But I could have also rotated a full circle, like spun all the way around, and then turned an extra 45 degrees, and I still would have ended up looking in this direction, and that angle, that full spin plus a little bit more, would have still given me a sine of root 2 over 2. So this is why, as you might recall, when we actually wrote out general answers to trig equations, we often had to write our answers like this. An angle of pi over 4 is a perfectly valid solution, but I could also add 2 pi to that angle. That is, I could add like 360 degrees. I could add a full spin. But I could add more than 1 full spin. I could add 2 full spins, or 3 full spins, or 400 full spins. That's totally okay. And so I'm going to go ahead here and insert a value of k, meaning that I can spin 2 pi as many times as I want. The value of k just has to be a nice integer value, meaning it's a negative or a positive whole number. It could also be the value then of 0, which is still considered an integer even though it's not negative or positive. So this would be communicating all of the angles that would face this direction out the unit circle. Now I can also state here that some other good values are going to be any angle that starts moving in the direction of 3 pi over 4, and again I could just add on as many full spins from that point as I want. Whether those are spins forward or even spins backwards would be totally okay. So I'll just write here on the side, here we have that k is an integer. So this here would be my overall solution. All of this. Notice again, I haven't just written down a couple angles, I've communicated infinitely many angles, and I've done that by writing out these individual equations. Each equation generates an infinite number of angles that all point out through the same red dot on the unit circle. Now, parts B and C are going to work exactly the same way, and so I'll ask you to go ahead and try those out, and then see if you can double check your solutions up online, hopefully get those questions right and feel confident with solving trig equations.